Hello, 9th of April 2024. Let's get started on problem 5. It's the first time I'm going to use the Peterson scalar product, or it's not scale, in a way, Hermitian product. So I'm gonna need to look up the definitions and the way. The plan is to delete the delay while I look up the definitions. So let's see how it goes. We are in Mn and P divides N. Note that Tp equals Un. Duly noted, but I guess I have to prove it as well. So let's look up the formula for Pn. And it works exactly when f and g lies in this space. And now we have P divides N, which means that chi of P vanishes because it's a Dedekind character modulo N. So that gives Tp equals Up. All right. So let's get working. And the definition of the and then the index of gamma, when we do this, it's actually gamma 1 of n, of level n. And now we can use what Up does. So of course we must make the change of variable. Omega equals Pz. And that means that if we write this with mu or u and v real, then they're just multiplied by p individually. So f of w d bar of w divided by p, y to kth, that becomes v to kth divided by p to kth. And here the p's cancel. Interesting. And so we just have to check what Vp does. And I know that this is just what it does, but there's some uncertainty in it. that was the definition of V, of course. You know what? It was terrible. I applied V here. So it's rather U we should have applied. And of course it deletes all the terms in the power series except those that are powers of P. Well, let's do that. So let's write F as a power series. I have no idea. Now if we start with the right-hand side, that looks more like what I was working on. Actually, that was what I was working on. So let's do that down here. And then change of variables. Oh, then we get a new domain. So maybe change of variables is not what we should do. I didn't change the domain up here. Well. This problem stops me. Hello, it's now Sunday. I'm sorry to report that I happened to solve the problem while rereading the last pages of the section. Sorry about that. But I'll just show you what I discovered. We actually should start on the left-hand side, and the point is to use proposition 47. So we have a matrix in the general linear group over the rationals, but we may assume A, B, C, D are integers. And then we define this matrix, which of course is connected to the, which operates exactly as the inverse. And then this relation holds, and that's actually exactly what we need. So I don't have to bother about change of variables and everything. It's all taken care of in the book. So let's get started. UP we use here. So it's 1 divided by P. F of Z plus J divided by P. G of Z. And now we must do our matrix magic. 1, j, naught, and p. So this way we have f of z the determinant is p, and d is p, so it's p to minus k, f of z plus j divided by p. So we use that. This is p to minus k halves, so it's p to plus k halves. And then alpha mark is p minus j naught 1. Oh, when the summation. So this is alpha j, and we sum over the j's from naught to p minus 1, alpha j, and then alpha j mark. And this is, of course, pz minus j. So let's put the sets on. G of pz minus j. And since g is in nk of naught here, it's periodic with period 1, so they all give the same no matter what j is. So we have p values giving the same, so it's p to k halves. And then we do the same. Actually, we can see it's just... oh, I forgot the determinant p to minus k halves. No, p to k halves. So altogether that gives p to k. And this is exactly Vp of G. And we're done. So the basic idea was to immediately think about this preposition, and then being quite clear about what U and VP do. Then it's an easy solve. While studying the section, I thought about the next problem 6 and believed that I had to compute the Peterson products numerically. So I tried to prepare that in Maple. It's not particularly difficult, but ensuring convergence, which is clear on a theoretical point, but actually getting terms enough to ensure convergence, I found that a little tedious. So I hope we can do it just operating on T2 and T3 by the definitions, but we'll see about that. But that's what I've spent some of the time doing. So it took a while before I was ready, before working on this problem. And I didn't mean to solve it, but suddenly it was apparent. I realized this, and then that might work, and it did.